Today we're going to talk about functions. Before we go into the topic of functions, we need to discuss a definition. What is a relation? After that, based on relation, we discuss what's a function. So first, a relation. What is a relation? A relation is a set. What are the elements of that set? Elements of the sets are ordered pair, x and y. The first entry, we call it the x entry. Second entry is the y entry. It's just a notation to show you there are two entries. And the elements, the first entry, which are your x values, we call it the domain. The y values, we call it the range. So all those x's create the set. That's the domain set. The range would be all the y values that belong to that relation. We call it the set of y values is called the range. Let's see an example. Let's say we have a set A, and this is notation for set. And normally this bracket. So something like 1, 2, 3, 4, 1, 4, 2, 3, minus 1, 0, A, B, B, A, C, D, doesn't really matter. Could be, I don't know, star, circle, whatever you want. This is the set A. So what are the elements of the set? Each one of these order pairs are elements. So here, let's say if they ask you what is the domain of this set A. Domain is all the x values. So all the x values is 1, 3, again 1. If it's repeated, we don't need to write the 1 again. So normally you ignore this. They already have 1. So I already mentioned that the 1 is in the domain. So 2, negative 1, A, B, C, and star. Okay. This doesn't need to be always numbers. It could be names, it could be letters, it could be shapes, as long as you fill up the two entries. So what is the range? Range of the set A. Let me use a different color. It'll be 2, 4. Again, you have 4. So I'll say 2, 4. There is no need to write 4 again. 3. Okay, 0. B, A, D, and circle. A, D, and circle. These green ones are the elements of the range value, the elements in this range set. It's not complicated. It's just the order pair. Every time you put an order pair in the set, also let's say if it was 2 and 7 here, you can fill up more elements in the domain. Is 2 in the domain already? Yes, it is, so there is no need. How about 7? 7 is not in the range, so I'm going to add 7 here. Okay. Sometimes this set that A that we wrote has finite number of elements. It has here, this is 1 element, 2, 3, 4, 5, 6, 7, 8, and 9 elements. With the 2 and 7, it would be 10 elements. So the set A has 10 elements. Each element is a order pair. Is an order pair. Sometimes they use this notation. It's not necessary to know, but if you see this, that means when they say cardinality of A is 10, that means that set has 10 elements. But the set does not need to have finite number of elements. It could have infinite number of elements. It could have something like 1, 2, 1, 3, 1, 4, and so on, and say every number. So this set would have infinite number of elements. What is the domain? Maybe I should have write this from here. Let me show you infinite a set with infinite inputs. So let's call this another example. Set B, let's say, has this form: 1 0, 1 1, 1 2, 1 3, and so on. And they ask you, what are the elements of the set B? So what is the domain? Domain would be all the x values. There's only one x value. It's 1. Everywhere else, all these x values are 1. So there is no need for me to write more than that. So I'll say, okay, there is one element. How about the range? Range could be 0, 1, 2, 3, and this dot 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 means it keep going. So 0, 1, 2, 3, and so on. And again, this doesn't need to be integers. It could be 0.0, something like 0.1, 0.2, 0.3, or square root of 3, square root of 2, square root of 1. All these are possible. You can have all those. Sometimes you can show a set, something like this, say 1, and I'm going to put all real numbers. That means I can put whatever I want for the range, as long as the domain is 1. Maybe I want all real numbers here and all real numbers there. All those combinations. So the domain would be all real numbers, the range would be all real numbers. Okay, we mainly focus on the functions. We do not focus on the relation much, but the definition of a relation builds the basic for the function. So the relation is just a set containing ordered pair. What is a function? Here. A function, we say normally y is a function of of x, if for every x that you pick in the domain, there is one y in the range, and not more than that. There is exactly one y. So if I pick an x value in the range, in the domain, there is exactly one y in the range. So here, let's look at this example. Let's say I call a equals to 1 2, 2 3, 3 4, 1 5, and ask you, is this a relation? Is it a relation? Your answer should be yes, it is, because all the elements are ordered pairs. So this is a relation. How about, is it a function? Is A a function? How do we check? You look at all the elements in the domain. So here I'm going to write the domain just. So you look at the domains are 1, 2, 3, and 1 again. So I don't need to write the 1 again. This is the domain. The range is 2, 3, 4, 5. Okay. So look at the elements in the domain and say the elements are 1, 2, and 3. If I pick the first entry to be 1, can I specifically find out what is the next entry? In this case, based on the elements in the set A, this one has entry 1 as your first entry, as the X entry, as well as the last one. I cannot say what is here. I can say it's either 2 or 5. To be a function, you should have exactly one of these. You cannot have both. So this A cannot be a function, not a function. Since there are two options to fill in for the Y value. For every X that you pick in the domain, you should have exactly one Y value in the range, not more than that. If I pick 1 in the domain, there turns out to be 2 different values. So for 1, there are 2 different values, 2 and 5 in the range. If the set A did not contain 1 and 5, if the set A was only 1, 2, 2, 3, 3, and 4, so if this was without the 1 and 5, erase 1 and 5, Let's say if this was not in the set. Then what happens to the domain? Domain stays the same. The range will have 2, 3, and 4. Then if I ask you, is it a function? Is A a function now? It's still a relation, but is it a function? You ask yourself, if I pick x equal to 1, what is the y value? There's only one y value, it is 2. What if I pick another entry? If I pick 2, I'm picking the elements in the domain. If I pick 2, do I have a y value? Yes, there is 3. If I pick another element in the domain, 3, do I have one y value? Yes, it's only 1, and it's 4. So this, and as long as you go through all the elements in the domain, that's enough for you to say yes, this is a function. So if we go back to the example that we did here, b, is b a function? The answer should be, is b a function? The answer should be no. Why not? Because there is a domain that contains one element, 1. And if I ask you what is the corresponding range value, it could be 0, it could be square root of 1 or 1, it could be 2, 3, and so on. So there are multiple answers, 0, 1, 2, 3, and so on. It's not the unique y value. So for this x value of 1, I have multiple y values. So this set b is not a function. Okay, so you check all the entries in the domain. If I pick a x value, something like 5, and I ask you what is the y value in this question, this example. If I pick 5 as an entry, what would be the y value? You have no y value. You say it's undefined. Why is it undefined? Because the 5 is not in the domain to discuss it. That means there was no x value of 5 to start with. So normally, if the x value is not in the domain, we do not really care about these. We only care about the x values that are in the domain. You cannot pick 5 to discuss it because it's not in the domain. Okay. This is one way to see if a relation is a function. There's another way. I'm going to go draw this example, write this example again and show you the idea. Here, B, set B, it was 1, 2, 2, 3, 3, 4, and then we had 1, 5. It's easy to do this when all the entries are numbers. This vertical line test that we're going to discuss, it's used when you have only numbers. If it was star and circle here, then it's not that easy to use vertical line test because there is no graphing involved. As we said earlier in the last section, you can always show the points in 2 dimension on a xy coordinate, rectangular xy coordinate. So let me draw rectangular xy coordinate. As I'll try to be as clear as possible. Okay, the point 1 and 2. Here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1 and 2, this is the point 1 and 2. The point 2 and 3, there's 2 and 3. 3 and 4, 3 and 4. 1 and 5, this would be 1 and 5. The same x value, but y value is 5. But what does vertical line test say? As we discussed already, b is not a function. It was not a function because of these two. They both have x value of 1, but the y values are different, 2 and 5. Vertical line test says, if you want to check to see if a relation is a function, just draw vertical lines. If it crosses more than, if it crosses 2 points at the same time or more, then that is not a function. Why is it not a function? Because they both will have the same x value. In this case, if you look at this, they both have the same x value, but the 2 points have different y value. This one has different y value of 5, the other one has different y value of 2. So vertical line test is the function, a relation is a function if no vertical line test intersects the points more than intersect the graph more than at one point. So sometimes you do not intersect at all. That's like those points that are not in the domain. We do not really care about those. So if I draw these lines, these vertical lines, and cross at 2 points at the same time in one of the lines, that means those 2 points have the same x value but different y values. If there were 3 of them here, still the same problem. Now you have 3 y values with the same x value. So this could not be a function. So to have a function, you check that if you draw the points and draw the vertical line, you cross more than once. If you cross more than once, it's not a function. If you cross exactly one, then it's a function. Sometimes you do not cross any points. That doesn't cause any issue. Our problem is with the points that are in the x values that are in the domain. Here, if you do draw this vertical line, for example, at 4, it just tells you that there is no intersection. That means 4 was not in the domain. If it was in the domain, there should have been a point somewhere here with the x value of 4. But this is normally used when you graph a function. So let me show you an example. So let's say instead of giving you a set A or B, if I said I graph A is given. Here you draw A. We know circle already. We discussed circle. Let's assume this is a circle. A circle is containing infinite number of points. So all those points along the circle, you can consider them single points. But if you connect them all together, all these could be a set of all those points on the circle. These dots, I just draw dots so you can see them as a point. But when you draw a graph, it's basically infinite number of points, you connect them together. So how do they look like? Yeah, anywhere that you pick, that's a point. There is a point here as well. So the set A is basically contains infinite amount of points. If you look at this question and they ask you, is A a function? Is A a function? That means this A is a set of points on the circle. Do you consider it to be a function? How do you decide? You do not have the option to write all the elements in C, but you can draw a vertical line test. I will draw a vertical line test, for example, here. What does it tell me? It tells me there are 2 points here. What is the property of those 2 points? They both have the same x value, something like 1, for example. Their y value is 2. The other one is -2. It's not 2 and -2. I'm just guessing. For example, if this was 1, those two are 2 and -2, then A has these elements, 1, 2, and 1, -2. That means A cannot be a function because you found 2 points with the same x value but different y value. So my answer would be no, it's not a function. What if A, so this is one way that we normally use to see if you have a function or not based on a given graph. What if A was only the upper half of the circle? Let's call this B. Is B a function? Let's draw a vertical line test. It crosses 1 time here. What if I draw there? Crosses 1. What if I draw here? Still crosses 1. Anywhere that I draw this, crosses 1. At this time, It doesn't cross at all. That doesn't cause any problem. It just tells you that there is no point here that belongs to the domain with the x value of whatever this is, maybe -3. So do we have 2 points on the same vertical line? No. So what does it tell us? That means b is a function. The answer is yes. So the upper half of the circle by itself is a function. Lower half similarly by itself is a function. When you put them together, then they turn out to be, it's not going to be a function. Okay. There's a vertical line test is very useful for checking if your graph, if your plot is a function or not. So it's a bunch of points. It could be infinite number of points, finite number of points. And you see by drawing vertical line through all of them to see. If you find only 2 points is enough. If I find 2 points with the vertical line going through those two at the same time, I can say that is not a function. For example, if the upper half of the circle there was another point down here, then when I draw this vertical line test and crosses these 2 points, I can say the answer is no, it would not be a function. But without this point, you have 1 point on the vertical line for every vertical line. The answer would be yes, it would be a function. This is, so far I've shown you 2 ways to see a function. To see a set, or in this case a function. It could be, you can write it in this form of a set. You can have it in terms of a graphing. There's another way to show it. Sometimes they show it through a mapping. Let me show you the mapping form as well. Let's say, for example, given A, set A, given as 1, 2, 2, 3, 3, 4, and 1, 4. The same example that we did earlier. And instead of giving you the set this way, they give you the set through a mapping. They tell you this is the domain elements, and here is the range elements. Domain elements were 1, 2, and 3. Range elements are 2, 3, 4, and 4 again. Okay. So now they ask you, and they provide you with this drawing and say 1 is going to the 2 with an arrow. This means this is 1 and 2. 1 is from the domain, 2 is from the range. 2 goes to 3, arrow from 2 to 3, 3 goes to 4, as well as 1 goes to 4. Now let me change this to 5, so we have a different number here. Let's assume this is 5. 5. Here, something like that. If I have, this is the domain and range. If I provide you this structure, you should be able to go backward and create the set. Create the set A. And if they say this is A, normally they write the A in the middle. And say these are the elements of the domain and range. And they ask you, is A a function? Is A a function? The answer is, based on the set format, you should say no, because 1 has 2 different y values. From 1, you get 2 y values. It's either 2 or 5. So if you look at the elements in the domain, there are 2 outgoing arrows. It means there are 2 different y values. So if you're given the mapping form, it's easier to see. If there are 2 outgoing arrows, that means there are two y values at least for that specific point. So I can say that it's not a function. But what if this set, instead of set A, we had, let me draw a different mapping. What if it was 1, 2, 3, 4, going to 2, 3, 4? and the arrows were like this. 1 goes to 2, 2 goes to 3, 3 goes to 2, and 4 goes to 4. Is this a problem? Let's call this B. Is B a function? You might say yes, you might say no. So what do you check? Our basic idea was you look at the elements in the domain. You look at 1, for example, and say, if I pick x equal to 1, what is the corresponding y value? There is only one y value, and it is 2 because there is 1 connected to 2. What if I pick 2 as an input? What is the corresponding y value? Corresponding y value, 2 goes to 3. 2 goes to 3, therefore 3 is the y value. I do not have any other choice. What if I pick 3 as the input? What is the corresponding y value? It would be 2. There's no other value. How about if I pick 4? The corresponding y value becomes 4 again. 4 goes to 4. So what is the answer? The answer is yes, it is a function. Because for every x value that I pick, there's only one option for me to choose for y. It's not multiple y values. In this case, if you look at the 1, 2, and 3, 2, they both have the same y value. They both have y value of 2. That is not an issue, because definition of a function is that for every x value you have to have exactly one y value. It doesn't say that for every y value you should have one x value. It says that for every x value you have exactly one y value. Later on, if we discuss inverse function, that means if you look at the function backward, if you start from here and look at the other way, then this would not be a function. It would not be inversible, because the reverse is not a function. But at the moment, we're only looking at the definition of function. We're only looking at, if I pick the input x's, do I have exactly one y value? Yes, I have exactly one y value. It could be the same repeated y value. That means your set could be something like, the set could be something like this. Be 1, 2, 3, 4, 5, all these numbers, they can go to 0. This is not an issue either. Still a function. Because for every point that you pick in the domain, as long as this is the domain and that is the range, domain and range, for every point that I pick in the domain, if I pick 5, what is the y value? 0. There's only one y value. If I pick 4, what is the y value? 0. 3, 0. This is not the issue that they both all have the y value of 0. It's the fact that for every x value you get exactly one y value. This is enough for me to say, yes, this is a function. I call it C. C is a function. Okay. Normally we say these were the y value, this is the x value, so they say y is a function of a. Function of x, sorry. X. If you look at it backward and say, is x is a function of y, that means if you change the direction of the arrows, I change the direction of the arrows the other way, then the question becomes, is x a function of y? The answer would be no, because you have multiple outgoing arrows. So it would not be a function. That's when we discuss the inverse function again. So in this case, this is a function. This is the 3 formats so far that you have seen. I've shown you either mapping or graphing through plotting points or set notation. Through all these you can see if you have a function or not. There's a fourth way to show functions. That's what we're going to discuss mostly. We do not discuss through mapping or set, because most of the time the function has infinite number of elements, so we cannot write them all down. So we write it in a shorter way. What we've learned is through this definition of function, there's a notation that you need to learn is f of x. This is not a multiplication of f and x. This f capital, the f stands for a function. Parentheses x means x is an input in the function. So we call it function of x. Okay. What are the outcome of the, if I give you the x input, what do you provide is the y value. So we say y is the same as the f of x. You're given an input, you expect an output. X is your input, y would be the output. Here's an example of it. We've learned linear equations, so linear functions. Let me write. Let's say an example. F of x equals x plus 3. This is f here is a linear function because it's in a linear format is x to the power 1, variable x to the power 1. Let me show you what is this set. Let's call this set A. I don't want to use f, but set A. What are the elements of the set? If I pick x equal to 1, what do you get for y? It would be 4. Because if I replace 1 for x, what do I get? 1 plus 3, it becomes 4. How about if I pick x equal to 2? What do I have? 2 plus 3. I'm replacing x with 2. I'll get 2 plus 3, which is 5. If I pick x equal to 3, I'll have 3 plus 3 and 6. So I can say if I pick x equal to 0.7, what is the y? 0.7 plus 3? 3.7. I have negative 9. Y value is negative 9 plus 3 minus 6. So instead of writing all these and so on, there are infinite of them. You can pick pi plus 3. Instead of writing all those, you can write the set A in this format. It's a shorter format to represent all those. It's all the y values. This is your y value are calculated this way. Given an x value, add 3 to it. So f of x represents the y values and says all those y values are only differ from are x plus 3. So the difference from x is 3. So if I pick x equal to 1, what do I get? 1 plus 3, y would be 4. I'll have 1 and 4. If I pick x equal to 2, 2 plus 3, it'll be 5. So I can show you this large set that has domain. What is domain is all real numbers. That means I can pick any x value that I want and replace here. 2 possible, 7 possible, 0.9 possible. Because 0.9 plus 3, it will give you only one y value. It's not multiple y value. It's a function. Because for every x, you get exactly one y value. You do not have multiple y values. So this is a form of a linear equation. It has x to power 1. It's we learned linear equation because all the variables had degree 1. And we do not want to write this set format. We can write the functions now in this shorter way. There are a bunch of cases that we discuss. Something is like f of x equals 2x squared plus 3x minus 1. This is a quadratic function. It's a function and it is quadratic. Normally, if they use f of x notation, they already assume it is a function, but sometimes you have to check. I will show you later how to check. It's not always possible to check, but if you can graph the function, it's easy to check through vertical line test. So let's say, how do we calculate? First, let's calculate. If I give you x equal to 2 and ask you what is the y value, because this set f has basically it's a function. Let's assume it's a function, And that means if I pick an x value, there should be exactly one y value. How do I find that y value? As I said earlier, f of x represents the y value. And it means replace whatever x value given in there. Let me change this 2 to a different number, just to not be confusing. So let me change it to 0, for example, is easier. So if I want to find out what is the corresponding y value for 0, this is a notation. You replace 0 into the function f of 0. F of 0 means I replace 0 into the function f, and I expect to find out what is that y value. I replace 0 for x. If you compare, every time I see x, I replace 0. 2 times 0 squared. For x, I replace 0 plus 3 times 0 minus 1. And if you calculate, these are just numbers. 2 times 0 plus 3 times 0 is 0 minus 1 would be negative 1. Did I get one y value? Yes, I got only one specific y value. And what? Y value is negative 1. You can try another number, something like 1. And how do you find the y value? Y value is f of 1. If they ask you what is f of 3, f of 4, that means that 3 and 4 are x values. What you're looking for is the corresponding y value. F of a constant, f of a number always gives you the y value of that number. So here, if I pick 1 and replace it into the function, I'll get 2 times 1 squared plus 3 times 1 minus 1. What do I get? 2 times 1 squared, 3 times 1, that's 2 plus 3, 5 minus 1, 4. That means 1 has one y value and it is 4. You're not supposed to get two y values. If you get two y values, that means that was not a function to start with. Okay, this is an example of a quadratic function. How about cubic? How do they look like? There's no different. Let me use different color. Sorry about that. Let's try a cubic function. Cubic function means there is a variable x with the third power, x cubed plus 2x minus 1 or something like that. It's a combination of a cubic. It could be 2x squared with squared, linear as well. That means the largest power that you see is 3. And now if I ask you what is f of 2, you can calculate 2 cubed plus 2 times 2 squared minus 1. And if you calculate that, 8 plus 8, 16 minus 1, 15. What does this information tell you? If I give you f of 2 equal to 15, what does it mean? That means there is a point 2 for x. This is the x value. And what you get at the end is the y value. This is the y value. F of 2 basically tells you the y value. So the point 2 and 15, that ordered pair belongs to the set, whatever this set is. If it's set A, belongs to the set A. What if I want to find out what is the corresponding f of 1? I replace 1 in there. 1 cubed plus 2 times 1 squared minus 1 turns out to be 2. So I'll get 2. Again, you get one x value, one y value. So x is 1, y is 2. So I'll have 1 and 2 belong to the set A. This is again examples of cubic function. It's not any different. We have the absolute value function. We discussed it. Absolute value, we discussed the absolute value, but we haven't seen it as a function. It's no different. F of x equals, let's say, absolute value of 3x minus 1 plus 5 or something like that. It has absolute value in it. So can I calculate f of 1? You can simply replace 1 in there. 3 times 1 minus 1 plus 5. This is just calculation. 3 times 1 minus 1 is 2 plus 5, 7. So what does it mean? It means there is a point 1 and 7 belong to the set A in A. This is representation of A. Or belongs to the function f in function f. Okay. Sometimes instead of using f over and over, they write g and say g of x equals to absolute value of 5x minus 2 minus 1. This is an example of using a different variable to represent a function. It's just the form is g of x. And then they tell you, for example, g of 0 is given whatever you can calculate. 5 times 0 minus 2 is 2, minus 1 is 1. Okay, so if they give you g of 0 equal to 1, that means if you replace 0, you expect to get 1. That means if I replace 0 for x, 5 times 0 is 5 minus 2 is 3. Sorry, this is supposed to be not. Oh, yeah, this is correct. 5 times 0 is 0, not 5. 5 times 0 is 0, minus 2 is negative 2, absolute value becomes positive 2, then minus 1 gives you 1. So that means 0 and 1 is in G. Okay? Because if I keep writing f, then you do not know which function I'm talking about. So notation f and g, they can write h of x. It's just expression of that I have a function. I'm going to call that function h. Input is x. Okay, this input can change as well. They can write it with a different name. You can write, for example, here, you can write k of z equal to z squared minus 1. You can think about this as exactly as f of x equal to x squared minus 1. It's just that sometimes they use f somewhere else, x somewhere else, so yeah, they don't want to use the same variable and function notation over and over. And this is exactly the same as that. Whatever is true for x squared minus 1, the same as z squared minus 1. Okay, the final example, let's talk about the rational functions as well. This is an important one, the rational function. Rational function, that means there is variable in the denominator of a fraction. So far, we only want to discuss the calculation. I just want to show you a format. X minus 1 divided by 2x plus 1 plus 10, for example. They ask you to calculate f of 0. What would be f of 0? That means you replace 0 for x. 0 minus 1 divided by 2 times 0 plus 10. And if you calculate, simplify it, this would be negative 1 over 10. So there is the point where x is 0, y is negative 1 over 10. They do not always want you to find it in the order pair form. They just ask you what is the y value, you say negative 1 over 10. So if the given x value is 0, y value is negative 1 over 10. What if the given x value is something like negative 5? What do I get is minus 5 minus 1 divided by 2 times negative 5 plus 10. If you simplify it, you'll get negative 6 divided by 0. What is negative 6 divided by 0? It is undefined. So what does it mean? That means if you give me negative 5, I cannot give you any y value. This is not possible. This is undefined. So this tells you something about the domain. What does it tell you? It tells you whatever was in the domain, negative 5 cannot be in it. Because if it was in the domain of the function, there should have been one y value here that this guy has an arrow toward it. But it is not possible to have negative 5 in the domain. So the domain would be whatever numbers are in here except negative 5. Negative 5 is not possible. Maybe there is another number that is not possible. But in this case, it turns out to be all real numbers are okay. I can pick any other number. 10 is fine. 12 is fine. There is always a number on the other side in the range. But -5 is not possible because it makes an undefined value. A fraction is undefined when the denominator is 0, and the only time that this denominator would be 0 is if I pick x equal to -5. For example, it's okay to place 1 into the function. You will have 1 minus 1 divided by 2 times 1 plus 10. How do you get this? 0 divided by 12. 0 divided by 12 is 0. That means I can pick 1. 1 has, if I pick 1 in the domain, there's a y value on the other side, and it is 0. It's not like -5. -5, in this case, does not belong to the domain. That's for later on we will discuss when we discuss domain of rational function and square roots and so on. But just make sure that you understand the concept. I'm going to stop here and hopefully discuss more later on.